Welcome everyone. In this video, I will teach you the topic number basis. Before I go into the topic in details, I want you to take note of the following points. 1. Any number written without a visible base is assumed to be in base 10. For example, this number 24, there is no visible base, but it's the same thing as writing 24 base 10. Then, if the base is not in 10, it has to be specified. For example, 24 is not the same thing as writing this, 24 base 5. So this one is 24 base 5. So it's different from 24. But writing 24 without a base is the same thing as writing 24 base 10. Secondly, no base will contain a digit that is equal or greater than the base number. What do I mean by that? For instance, if I write 37 base 9, this 37 is a valid number in base 9. Why? Because the digits there, which are 3 and 7, none of them is up to 9. So this is a valid number in base 9. But if I write 53 base 4, this is not a valid number in base 4. The reason is it contains a digit which is 5. 5 is greater than 4. So this is not a valid number in base 4. No base will contain a digit that is either equal or greater than the base number. Thirdly, there are some bases that have special names. For example, base 2 is also known as binary. Base 8 is known as octal, while base 10 is known as decimal or denary. Lastly, in number bases, there are two major conversions that we do. Either you are converting a number that is in base 10 to other bases, or you are converting a number in other bases back to base 10. This I will summarize with this simple sketch. Base 10, one side, other bases 2 to 9, the other side. So the conversions we do in number bases is either you are converting a number that is in base 10 to other bases, or you are converting a number that is in other bases back to base 10. That's the summary of what we do in number bases. Next, we are going to see these two major conversions. I'm going to use some questions as illustration to explain what we mean by converting numbers that are in base 10 to other bases, and then numbers that are in other bases back to base 10. We have 4 questions on the board. This part of the board says convert the following: 124 base 10 to base 9, 13 base 10 to binary. Now, these two questions talk about numbers that are in base 10 being asked to be converted to other bases. Remember, other bases are from 2 to 9. Why this part of the board looks at numbers that are in order basis 1011 base 2 and 34 base 6 being converted to base 10. One, two, four, base 10 to base 9. To convert from base 10 to other bases, there is one method. And that method is like a long division method. 124 is a number that is in base 10. We are converting to base 9. So it will be the dividend, while the new base will be the divisor. In number basis, as you do this division, please, you have to write down the remainder. The remainder forms the answer. Any division you make, you write down the quotient and carry the remainder, write down the remainder the other side. Now, 9 divide 124. We can take it piecemeal. 9 divide 12 will give us 1 remainder 3. 9 divide 34 will give us 3 remainder 7. So this R stands for remainder. 13 remainder 7. We continue. You don't stop until you get 0. 9 divide 13 will give us 1 remainder 4. 9 will divide again. 9 divide 1. Of course, it can go through. 1 is not divisible by 9. What do? You write 0. Remainder that 1. So you stop the division once you get 0. And how would you get 0? When the dividend is less than the divisor, that is when you write 0. In the course of the division, once you notice that the dividend is less than the divisor, the next thing you write is 0 and take that dividend as the remainder. Now, the division is over. To get your final answer, you read upwards. From down, you read upwards. So the answer is 147 base 9. That's the final answer. So the second one, 31 base 10 to binary. Still use the same method. 31 will be the dividend, while the new base, which is, remember, binary is something as base 2. 2 divide 31 will give us 15, remainder 1. 2 divide 15 will give us 7, remainder 1. 2 divide 7 will give us 3, remainder 1. 2 divide 3 will give you 1, remainder 1. 2 divide 1. Now, the dividend is less than the divisor. So you write 0 and carry that dividend to write it down as the remainder. Now, you read upwards. Our final answer is 11111 base 2. That's our final answer. Now, to this side of the board, we are going to look at how to convert numbers that are in order basis to base 10. In this case, there are 2 methods you can use. The first one is repeated multiplication method, where you use the given base number to multiply each of the digits. So in this repeated multiplication, what do? You write out the digits one by one, and you multiply by the base number, which is 2. The way this method works is that each time you multiply, you add. 2 times 1 will give us 2. The next thing you do is you add. If you don't multiply, then you don't add. But once you multiply, you must add. So multiplication and addition, they go hand in hand. 2 plus 0 will give us 2. Should we multiply again? Yes, because we still have 2 digits left. You only stop multiplying when you discover that there are no digits left. Because we still have 2, we have to continue. Times 2 again, because the base is 2. 2 times 2 will give us 4. You bring down and add. It will give you 5. Should we multiply again? Yes, we still have a digit which we'll add. So times 2 again will give us 10. You bring down, and your final answer is 11 base 10. Now, this method is repeated multiplication method. There is another method which we'll call expanding to a given base. Expanding to a given base method. What do we do in that one? You write out the original number, base 2. Each of the digits multiplied by 2. Then you assign powers. You assign powers to the base number, not on the digits, on the base numbers. Then, applying the knowledge of indices here, 2 raised to the power 3 is 2 times 2 times 2, which is 8. 8 times 1 will give us 8, plus 2 raised to the power 2 is 4, but 4 times 0 will give us 0. 2 raised to the power 1 is 2. 2 times 1, 2. Anything raised to the power 0 is 1. So 2 raised to the power 0 is 1. 1 times 1, 1. Finally, add all of them. 8 plus 2 plus 1. That will give us 11 base 10. Now, you discover that you will get the same answer. Whether you use repeated multiplication method or you use expanding to a given base method. Once you use it correctly, you are supposed to get the same answer. Now, there is nothing bad if you know how to use the two methods. But remember, in an exam, you cannot use the two. So my advice is look at the two methods. Anyone that is more convenient to you, use that one. The next question, 3, 4 base 6 to base 10. I'm still going to use repeated multiplication, after which I will use expanding to a given base method. Now, for repeated multiplication, write 3, 4. What are we going to multiply with? We're going to multiply with the base number, which is 6. We use 2 here because 2 was the base number. We are going to use 6 now. 3 times 6 will give us 18. And remember the procedure. After multiplying, the next thing is to add. You bring down and add. 18 plus 4 will give us 22. So 22 base 10. Will you multiply again? No, because there are no digits left. If you are interested in expanding to a given base, using expanding to a given base to solve the same question, you write it like this. 3, 4 base 6 is equals to 3 times 6. We are multiplying by 6 because 6 is the base number, plus 4 times 6. Remember, assign powers to the base numbers, not on the digits, but on the base numbers. Look at it. Now, the next thing is applying the knowledge of indices there. 6 raised to the power 1 is 6. 6 times 3 will give us 18, plus anything raised to the power 0 is 1. So 6 plus 0 is 1. 1 times 4 will give you 4. And finally, 18 plus 4 will give us 22 base 10. We can see that whichever method you use, as long as you use it correctly, you're supposed to get the same answer. So in summary, these are the two conversions we do in number bases: from base 10 to other bases, or from other bases to base 10. On the board, I have a question that says 5, 3 base 8 to base 4. Now, if you look at this question, you are converting from base 8 to base 4. It's no longer from other bases to base 10. Rather, it's other bases to other bases. Remember, I told you before that our conversions in number bases that are grouped into two. Base 10, other bases from 2 to 9. And I said that all conversions we do, either you are converting from other bases to base 10, or you are converting from base 10 to other bases. But if you look at this type of question, from base 8 to base 4, it looks as if you are starting from other bases and you are returning back to other bases. That's what it looks like. But in reality, it is not so. So this is not the correct route. It's not when you start from other bases, you return back to other bases. You must touch base 10. So the correct procedure is from other bases, you go to base 10, then from base 10, you go back to other bases. What do I mean by that? Now, this 5, 3 base 8, you should convert it to base 4. First of all, convert 5, 3 base 8 to base 10. So 8 raised to the power 1 is 8. 8 times 5 is 40. 8 raised to the power 0 is 1. 1 times 3 is 3. And you get 4, 3 base 10. So this is what we have in base 10. We have successfully converted 5, 3 base 8 to base 10. But remember, this is not the final answer. The answer should be in base 4. And because of that, you need to convert this number to base 4. And converting a number that is in base 10 to base 4, remember the method, don't forget the long division. 4 divide 43 will give you 10, remember 3. 4 divide 10 will give you 2, remember 2. 4 divide 2 will give you 0, remember 2. You read upwards. So final answer is 2, 2, 3 base 4. So the final answer of converting 5, 3 base 8 to base 4 is 2, 2, 3 base 4. So in summary, what I'm trying to point out is that there is no how you can start from other bases and end up in other bases without touching base 10. So when you move from other bases, you stop momentarily at base 10 before you continue back to other bases. Thank you for watching the videos on number basis, and see you soon.